Uh, okay, guys, if you want to grab a seat there. We'll get started a little bit late as usual. So just a couple of things, the agenda before we start. So my name is Sean Murphy, one of the now two guys who runs the GTUG, the other is Owen Bailey. He's in the final stages writing his PhD thesis, so he's not going to make it here tonight. We've got a few things on the agenda tonight. It's all about social, is going to be the core of it. A few guys have approached us and asked us if they'd be, if it'd be possible for them to show their wares, do a pitch of some stuff that they've been doing, and they're going to give some demos of the stuff. We said we'd give them 5 minutes. They're, I think, basically trying to get people to try out their system and let people know what they're doing. Then Connor Tracy from Facebook is going to talk about building open graph apps on Facebook. We'll have a short break. Fergal Reid from UCD is going to talk about some social network analysis research work that he's working on. A couple of things at the end, and then we're going to go for a pint afterwards. The session is being recorded, and we will put it up on the YouTube channel eventually. Communications hashtag Dublin GTUG, and links to anything you want to find out about us is on dublingtug.org. So with that then, we'll move over to Alex. How do I pronounce your surname, Alex? Passant from Civil, who's, what do you want it in presentation mode? No, it's this Alex Passant from Civil, who's going to talk about their music discovery platform.
Thanks. Thank you. Good evening, everyone. My name's Alex. I'm from Civil. We're a small early-stage startup from Galway. Even though I'm French, you can probably hear that with the accent. So our goal with Civil is to transform YouTube into a music platform. So the problem we had is that there is lots of music on YouTube, but if you don't really know what you want to listen to, that's quite difficult. So let's say you want to listen tonight from punk rock or R&B. If you don't know the exact artist you want to search for, that's quite difficult. So we've developed a browser extension that's for Chrome right now, and I'll show you what it does. So that's it. So that's a Chrome plugin. So if you go on the Chrome store and install it, as soon as you have that, and when you go back to YouTube, you get the new things that appears on the right when you start watching a video. So you get a full set of recommendations that give you some new artists to listen to. We give you also the biography of the artist and some fact sheets. So in that case, for an artist, we get a bunch of facts like what are the influences, what are the collaborations, what was the label, the genre, and so on. And if you click on any of these facts, you can get additional bands that match the criteria. You get also recommendation, and for each of them, we explain you what are the relation between the artists. So in that case, you're browsing Johnny Cash. We give you Elvis Presley as a recommendation, and we will let you know all the relation that link the two artists together. And once again, you can decide to check one relation and discover some more music. So that's what happens when you start browsing some music video. But you can also search for music directly. So we get that feature on the right, the music search, and there you can combine different criteria. So if you want to listen to a particular genre, you can start typing the genre, let's say, that is psychedelic rock, and you will get all the bands in YouTube that are playing psychedelic rock, and you get some videos. You can also refine the criteria, so if you want not only to get a genre, but also get a location because you want to listen to something very narrow, you can add that, and you can also add things like the activity if you want to listen some, for instance, only bands from the 60s or stuff like that. So that's what we're doing. You can get the plugin on civil.net, and I want to talk a bit about how that works in the background. So how we're building that, we are aggregating data about music artists from stuff like Wikipedia, Freebase, music brands, and Facebook, and we build from that a big graph of artist and music information that links together things like genre, instrument labels, and so on. And then on the background, we get some NoSQL storage, so we get a big graph database, and on top of that, we get the Chrome plugin that you've just seen. If you want to chat about that a bit later, I'll be around. We're using as well HTML5 and jQuery for the interface for local storage and so on. So that's the current release, and probably next week we'll launch the new one, and I got a few screenshots to show you what happens there. So the first thing is that the user interface is much more integrated into YouTube. So we want to make the user experience really more as if it was directly something provided by YouTube and not a plugin that you have there. And one cool thing that's interesting is the social dashboard. So we're using actually Facebook Open Graph, and you can log in on our platform with Facebook Open Graph. And then when you go on YouTube, you get a bunch of recommendations based on what you liked on Facebook and what your friends liked on Facebook. And what the idea, once again, is to discover some more music on YouTube using a bunch of data that is available on, openly on the web on lots of platforms. So that's it. You can get it on cevl.net, SEVL.net. So far, that's only for Chrome. We're working on other browsers, and I'm happy to take any comments later in the evening. Thanks.
Thanks, Alex. Very interesting. So if anybody's interested in music discovery, you can talk to Alex at the break or later afterwards in the pub. Next up is Brendan O'Driscoll. More music stuff. Brendan O'Driscoll is going to talk about Soundwave. So.
How you doing, guys? My name is Brendan O'Driscoll. I'm CEO of Soundwave. So we're currently in the NDRC Launchpad incubation program. So we're about 2/3 of the way through that. And what we do is we track in real time what songs people play and where they are when they play them. So the aim of this is trying to figure out essentially exactly what songs people are listening to. There's multiple different outputs of this. The first is what we're trying to do for users is create hyperlocal charts for music discovery. So you should be able to plug in and see what songs people are playing in Times Square, in Camden Street, in their local office, their gym, or see what their friends are playing. So it's music discovery by location and by people. The flip side of this then is what we're looking at doing is setting up music analytics for the music industry. So what we're trying to do is provide real-time market analysis for the music industry. So with the rise of illegal downloads, I think 95% of music downloads are now illegal. With the rise of illegal downloads, it's done two things. It's cut off the primary revenue stream of the industry, and it's turned the light off over their market. So they can no longer understand what their market is doing or how their market is reacting. What we're hoping to do is to be able to tell the market what their consumers are doing, what music they're listening to, and where they are, and then they can target them with real-time campaigns, promotions, tours, and figure out how to increase their returns on investment for attacking this market and monetizing the market. So what I wanted to show you just very quickly was a very quick demo. So what we've done is we've built an Android prototype. What the prototype does is when a song is played in Music Player, it can tell through distinguishing from the ID3 tags what song has been played, then matches this with location and a time tag, and pings it to our database. So what we worked on quite hard was not disrupting the normal listening routines of a user. So a user goes about the normal routine of opening up their music player and listening to their music, and then we can tell in the background what songs are actually being played. So I'm just going to open up our smartphone app very quickly. Going to play a song. So the song is now playing on the regular music player, and then I'm just going to search for that song and see if we can find it over our location now. Just going to do a search here, and then if we just scroll up to Dublin, I was actually playing this song a few times on the way over here, so you can see that the information has been captured, and then you can see where we're over here. So you can scroll right into the actual building we're in. We played it in the lobby earlier on, and then we just played it in this room here. So what we're trying to do to separate ourselves from some other potential competition is that we can actually increase the location, the granularity of the location right down to a building level. So you could be walking down the street, you could see in real time what songs people are listening to around you. So yeah, I just wanted to give you a quick demonstration of what we're up to. We'd love to talk to you further about it. We're looking for people to hopefully trial our demonstration, our prototype app, and trying to give us some feedback, tell us what's working and what's not working. And we're also potentially looking for a developer to join the team. So that's all we have for you today. Thanks for your attention.
It was very cheeky there, Brendan, getting in the recruitment a bit. But I suppose if you're trying to do CEO of a company, you have to be a bit cheeky. A question about the Android app: is the Android app available, or is it a separate app? Okay. Testing on it. Okay, so you might send it out to the list if you want people to get it together. Yeah. Okay. Cool. Okay, so next up is Brian Henry. Brian Henry is promoting Sortons. So Brian's going to. It's a social reservations app. So over to you, Brian.
How you doing? I'm Brian, and I'm here with two guys I'm working with, and we are Sortons. I'm working on a social reservations app for Facebook, and it came about because I was working with a restaurant, and I had to kind of prove that it was worthwhile, that they were paying me to update their Facebook page, and there was no means of conversion and no real way of proving return on investment on anything I was doing on the page. So we came up with this Facebook app. It's pretty straightforward. Button goes at the top for reservations, and it brings you to our app, which asks guests the number of seats they're going to take, and obviously then the date and the time, and gives them space to ask particular requests, and then opens kind of a two-way communication with the restaurant. It's built using Google Web Toolkit and is run on App Engine. And if you don't know the Facebook platform, that's just an iframe there. So it's almost out. It's really just an external website inside. So once the user requests the reservation, they're asked, they have to give us permission to access all their information. And once they do, we send real-time notifications to the restaurant, who's then presented with this dialogue for confirming, denying, or suggesting alternative times for the reservation. And then they can reply to whatever the user has requested. And then later on, other participants in the reservation can ask questions at this point. This particular view we also have running in MGWT, which is a mobile GWT library for various WebKit. And we're going to wrap that in PhoneGap for our version 1, which should be launching very soon, we hope. We've put a lot of work into this lately. So today we're really just out here to show people, get some feedback, and give ourselves some motivation. This is what the user then sees when they've made the reservation. They're able to tag their friends, they're able to speak privately with the restaurant, and they're able to speak privately with their friends. And this particular widget that you see now, we have to make ourselves. So a lot of the things that you might like from Facebook, and we do, trying to imitate their style to make things as seamless as possible. You then have to go and do yourself. Then there are dialogues that Facebook do provide like this. This is the request style, this is the request dialogue, and this is kind of on the periphery between your app and Facebook, and it's kind of an anti-spam measure. Any notifications inside Facebook have to be user initiated. There are one or two like this, and we've had to make a lot ourselves. Some people have been blocking platform access to Facebook apps. For example, the previous widget that you saw where we were tagging 7 of my friends just don't show up because they've delved into their Facebook privacy settings and blocked access. And there was actually an article on Boing recently, if anyone reads it, that was a bit of, Corey being very scare tactic. But in fact, Facebook's become a lot more secure. The permissions dialogue that you saw there is very new and is a lot stricter in how clear you have to be than they were a few months ago. And what users can previously, if an app asked for permissions, you had to give them all or nothing, and now users can select to only give some. So they're becoming a lot better with their user consideration, I guess. When a reservation is made, it posts in the user's timeline, and this is from our point of view to give advertising to the restaurant. And when they tag one of their friends in the reservation, that friend sees the request up here, and if that friend follows through on this request and goes to the view reservation view themselves, it will post on their timeline and in their ticker. So we're hoping that reservations made through our app will give the restaurant much more exposure than they will get through any other reservations. I'll briefly show kind of what we're working on for our management interface, an activity stream of what has happened today, and then tonight's reservations with photos of the users. We're going to build this into a CRM that will give the restaurant statistics on how often the users come, whether or not they like the page, anything they've posted on the restaurant's page, check-ins, and then what influence they've had. The other main thing we want to do is tie in with the Insights API and then show restaurants the effectiveness of posts. So if there's a peak in reservations following what they've said, they'll be able to, again, prove the return on investment. That's it. The platform is pretty good. One thing we want that we don't have is access to the phone number, which was available and deprecated. So again, Facebook are kind of tightening up on some things. And the other two main things were it's in an iframe, so you're not able to use the back button, which kind of messes us a little, and you're not able to warn people when they're leaving. But overall, we think we're onto something good. So anyone interested, talk to us after.
Okay, thanks for that, Brian. A few issues there that you flagged with Facebook, so I think Connor, I don't know if Connor will be able to deal with all of them, but Connor Tracy from Facebook is Facebook Developer Relations is up next. We're going to try and get rid of this, you see the small lamp stuff, Connor.
Hi everyone, I'm Connor Tracy from Facebook, and this is my colleague Alex, and we're going to talk to you about building successful Open Graph apps. So I'm going to talk a little bit about the concept, and then I'm going to give you an example implementation. If I can get this clicker to work. Okay, so I don't know how many people have heard about the Open Graph, but the social graph's the core of what we have at Facebook. It's everything that drives everything that appears on Facebook. It's all of the connections that you make with the objects and the friends that you have on Facebook. So we've extended that to include the Open Graph, which is allowing third-party apps, third-party developers to include their own objects on the Open Graph and allow users of Facebook to connect with those objects. So making an object in Open Graph involves a person, an action, and an object. Your app can model user activities based on objects and actions. Users interact with the objects, and their actions are published to timeline. So in Open Graph, objects define the nouns, and the actions are defining the verbs. So for example, Alex cooked a recipe, or Alex watched a video. So the user connects with the app, the action is generated by the user's usage of the app, and the objects, some of the objects that are contained inside the app. So Open Graph supports composite objects, so you can build an object hierarchy based around the objects that you have inside your app. So for example, a user can watch a TV episode. The TV episode can contain actors. They're like external profiles. It can also have writers, directors. The TV show can contain a number of episodes. So you can build up what's called a composite object based on the objects that you have inside your app. So actions can be published against all of the objects that are available. So for example, you can watch an episode, you can rank a TV show, you can follow a director or a writer. So to build these apps, you use our developer app tool, where you can define the objects, the actions, and the aggregations. So for example, you can create an object and give it a bunch of data, and then you can define actions on those objects. I don't know how clear that is actually on the screen. Okay. And then you can build aggregations on the objects and the actions. So why do you want to do that? What's important about Open Graph? It's important to help users build a relationship with your brand. Open Graph helps people do that. It increases the engagement for your app. It increases the exposure to the objects in your app. It gives you increased distribution through the timeline, through the newsfeed, and through the ticker. And it gives an authentic user base, so you get some social context, and people trust their social context. When they see their friends using an app, they feel more confident, they feel more relaxed about interacting with that app as well. So best practices. These are some of the things that we try to guide people in how to build these apps and how to make it a little bit more user-friendly. So it's really important that the user can connect to the app using their Facebook profile. So that means making the login as easily as possible, making it as obvious as possible where they can log in using their Facebook profile. You want to show the user the benefit of connecting. So that means that showing the user that they're going to be published into their timeline, that their timeline is going to become a bit more personalized to them based on what they do inside the app. You only want to ask for the permissions that you need. So you saw in the dialog box that was in the previous demo that there's a lot of permissions that you can ask for, but you want to keep that list of permissions as small as possible so that users feel more trustworthy. And you want to tell the user in advance what they're going to be doing. So you don't want the app to be making any surprises. You don't want it to be displaying content on their newsfeed that they didn't want to share. You just want to show them exactly what it is that the app's going to do. So we'll walk through an example implementation of this, and then we'll do a live demo of how to do this. So you start off with the user. When they access the app for the first time, the app asks for the permissions that's needed, and it gives them access to the basic information. So this is just the basic information that they get from the platform. So from now, once the user's granted permissions, the app can publish actions to their timeline. So once the user is identified, the app gets an access token, which is what it uses for all of the action publishing. So the app's able to get some basic social context about a person once they start interacting, so they can ask for more data on this, but they start off with the very basic information about your name, first name, surname, what gender you are, time zone, locale, and this is the most basic information that you get for an authenticated user. You can extend that and ask for access to their interests, their photos, their check-ins, their friends' information, and you can get that information from them as well, but you do have to ask for extra permission to do that. So this allows the app to provide some social context to the user. So for example, a quick rating that says, "Hi Alex," or "Here's some stuff that's recommended for you based on your interests." So building up an object. To define an object, you have to have a publicly available URL for each object that's available. So if these are articles, you want each article to be on its own URL. If it's a video that you're building a video app for, each of these videos have to be publicly accessible. And you add some metadata to the HTML that's returned from each of these URLs. So the metadata describes the object to Facebook. So this is the title for the object, the URL it's accessible at, a basic thumbnail picture for it. These are like basic things that have to be added. And you can add some extra information to describe the object hierarchy as well. So this is all just meta properties. For example, here you can see that this is a type video, and it has extra information about the actor, the director, the writer, and some tags. So in this case, this is a French TV show, an episode of a French TV show called Plus Belle la Vie, and Alex is going to watch it. So once he watches the video, it says, Alex watched an episode of Plus Belle la Vie. So this action is created as a result of Alex interacting with the app. And from that, a story gets published to Alex's timeline. So to do this, the app makes a call, a HTTP post to the URL that you can see there. This describes the action, the object that's being interacted with, and then some information about, in this case, when it started and how long it's going to take to expire. The graph in this case will respond with an action ID. The action ID is used for actions that are mutable. So for example, you want to change the finish time of an action if it's an event that's going on, or if you want to remove that action if it's something that's maybe time-based. So once the action is published, Facebook will get the information from the meta tags using what we call our linter. So it reads all the information about the object, and it's able to generate some usable visual stories about that on your timeline. So it'll use the thumbnail, and it'll use the title, the description, and any of the extra metadata that's in there to generate a user viewable timeline object. So the exposure happens in several places. The ticker will show what you're doing, so your friends can see what you're doing in real time. There's aggregation boxes on the timeline, so whenever you go to visit your timeline, it'll show you a summary of what you've been doing. If you're viewing a friend's timeline, it'll show you what they've been using the app for. And what? And the app view as well, yeah. So you get the app view as well, finally, which shows up all of the information that you've been publishing for the app. So any actions that you've published and your most popular objects that you interact with, they'll all be available in the app view. Okay. So bear with us, we're just going to give you a quick demo using an app that we built earlier. Okay. So this is a really, really basic demo that we put together earlier to give you a better understanding of how this works. We've built a very basic app. It's called Pet Keeper, where you have a bunch of pets that you keep, and you can feed your pets, you can pet your pets, you can do what you want to do with these pets. So this is a really basic, simple demo that will just give you an idea of how to start publishing these OG actions for your app, and hopefully give you some ideas of what you can do inside your app and how easy it is to do that. So first of all, we've built our app using the developer app tool. We've defined the objects that are going to be used in that app. So in this case, there's going to be pets or pet food. And then we've defined the action types that are possible on these objects. So for example, you can feed a pet some food, or you can pet them. You're struggling with this. Should we change the screen? Yeah, you can. Sorry, bear with us. Okay, so we've configured our app to have a couple of different objects and some interaction between those objects through the actions.
For example, if you want to build a composite object, you're going to define into the properties. You're going to define here, you can add, for example, if you want to have pet food connected with your pet, you will, as we showed before, you can have a video gonna contain actors, maybe pets gonna contain pet food, but we can imagine something different. You can build your own graph indefinitely, as you want. So here, you define another properties like species for your pet species. I don't know. What are your species?
Yeah, species.
Basically, your actions that will interact with your pet objects, so feed or pet, and you're gonna have some standard properties, and after you can have some custom properties as well, which is food. I don't know this one. And this is a basic, actually, the verb that's gonna appear. So you can personalize the conjugation, I guess, and which style is gonna appearing on your timeline, basically the style of aggregations. So this is good for that. You put aggregation as well.
Yeah. So there's three things you build here. You have to build the actions, you have to build the objects, and you have to build the aggregations. Without those three things, your app's not complete. So the objects are first. Obviously, you define the objects that exist in your app. In our case, it's a bunch of animals that we're going to call pets. Our actions are going to be some of the actions that you can complete for those objects. So you can pet a pet, you can feed a pet. The aggregations, there are different ways that these actions appear on your timeline. So once you've done a bunch of these actions, we'll aggregate them on your timeline, so you'll be able to see what you've been doing with your app. Your friends can see what you've been doing with the app. So you define different aggregation types for the different actions that you have and the different objects. That's a very basic example. We're going to actually show you how these objects and actions get published to your timeline. So we've built some basic HTML pages here for your pets. Yeah, that's fine. We've done that.
Basically, we don't show the authentication part, but it's really important actually the authentication part and how you recognize the user. Because first you're gonna authenticate your user first, ask for permissions to publish on his behalf. But after you will need to recognize the user as soon as he arrives. So we usually use client-side authentication for that. So, but let's go to pet or feed Wolfie.
So yeah, this is Wolfie. So normally what you'll do here is you'll build in the proper authentication. As Alex says, you'll have a button that connects you to Facebook. This will get your user profile and the basic information that you need. It'll also pop up with a dialog for permissions. We've cut ahead from that, and we've already got an access token here, which we've just coded into the example. So this will only publish for me, right? But normally what you'll do is you'll build the authentication into your app as part of your registration. So in this case, we're just going to do a basic call to our graph endpoint, which in this case will be to pet Wolfie. So to do that, you pass the object, which is the URL to our pet here, the access token, which you've already fetched as part of your authentication, and the action URL, which is the graph.facebook me petkeeper pet. So all of these actions are namespaced to your app. So if you create a pet action and somebody else has another app, they can also create pet, but it's namespaced to them. So as long as the namespace is unique, you can have whatever action you want. Okay, so we're doing a call to the graph endpoint for pet. In this case, we're passing Wolfie. So this is just a basic curl call. You can do it with a get or a post, depending on how you want to do it. It can be client-side or server-side. In our case, it's done in a terminal, just for the sake of the demo. We've now published an action. We got back an ID. So the call to that endpoint returned an ID that we can then use, and we could store that on our app if we want to do future mutation of that object, whatever it is. So do you want to show that on the timeline? Can you tell this is our first demo, by the way? Never mind that. We'll just show it on the timeline. Okay, so we've just done that action, right? We've just so we've just petted Wolfie, right? So it shows up in our activity log. So this shows all the recent interactions I've had on multiple apps, right? So this isn't an aggregation that's unique to the app. This is just recent activity that I've completed. So I'll see that, but my friends won't. They'll just see the aggregations for the app. So I petted Wolfie. That's great. If I go to the app tab for PetKeeper, I'll be able to see everything that I've done on the app recently. So what we have here is a bunch of aggregations. So you can see that I've petted Wolfie 4 times, I petted Felix once, and I petted Ramses 1 time. So that shows you what I've been doing in April, which is obviously right because we only just did this earlier today. If you want to post a couple other actions, Alex, you'll be able to see that this comes up with different aggregation based on the access. Yeah, let's go feed Ramses, right? Ramses is a pretty famous hamster. So we're going to feed him some nachos because that's what he likes to eat. Right, so you can see it's done a call to the Graph API endpoint. It's got back an ID that then we can use to refer to that action if we want to. We can get more information about that action. We can change some of the attributes of that action, add a message to it, do whatever we want to do. Yeah, so on the right-hand side there, you can see that that I fed a pet. If I click on that, it'll bring you to Ramses. Right, so we fed Ramses some nachos, and that shows up there. So the basic steps are create your objects, create your actions on those objects, create the aggregations, which determines how it's going to display on your timeline, and then build your app around the publishing of those actions. So We didn't talk about authentication. I think we're going to leave that out of this demo. It's really important that you get the authentication right. People want to feel like they trust your app. If you're going to be publishing stuff to their timeline, then you want to ask for the right permissions so that they don't feel awkward about granting those permissions. So that's pretty important. Once you've authenticated, you can start publishing these, and it's basically just either client-side or server-side calls to the Graph API. So this is an example action and the metadata that you get back from that action. So in this case, you can see that we petted Wolfie. We didn't add any comments to it. It's an action type of pet, and it's against a pet called Wolfie, right? So you get this back every time you do a call to one of these actions once you've got an ID for it. You can use that whatever way you want inside your app, and it's up to you to determine how you want to use that.
So you can add a comment per actions, and you can retrieve those comments, or you can add those comments on per action level. Let's say, so let's add some comments. You have to do a pause, so here I'm gonna use a little trick. It's just because we use client side as well, we can do that client side, so we can just add this little emulation. And here you have your comments. Let's see if we actually get it. And here you have your comments. You can delete it and do whatever you want from your app.
Okay. I'm not sure if that's too technical a demo, whether it's not technical enough, or whether it's just actually boring because of the amount of code. So please feel free to ask us some questions about this. Anything that you want to do, any ideas that you have about your own implementations, please just go ahead. So any questions? The objects are all public. The objects themselves have references to the app that's going to be using them, so other apps can't publish to those actions, to those objects. You have a reference to your app ID as part of the metadata, so if you want to show, let's say if you just show the source code for one of these pets. Yeah, so if we look at Wolfie, right, the metadata that's in there is publicly visible, but it has a reference to the app that we're using in this case. So you can see here we've got the FB app ID. And that's our app, right? So other apps can't start publishing to these. There are shared actions that are open actions. So, for example, listen, read, watch. These are available to everybody that wants to build an app. So, if you've got some content out there, and if it's of type article or blog, then it's possible for you to publish a read action from whatever app you want to do. So, if you want to build a client reader that reads from, like a Google Reader type rich client app. Any of the objects that are marked with the article or blog, you can publish them from your app. So it'll end up saying that Connor read an article on whatever app. And there are a few implementations of this already. I don't know if you've heard of Rockmelt, the browser. Yeah, so Rockmelt's doing this exact same thing. And to answer your first question, they all have to be public. So if this is an object that needs to be privatized, then you need to have a public URL that can still get basic representation about the object. That's not public information. I wouldn't even know where to look to find out, I'm afraid, but I don't think it's information that we publicize. No, there's not, but the other restriction is that whenever you're creating the app, you have to declare the domains that are going to use that. So if somebody wants to reuse that app ID and store it on a domain that's not one of the registered app domains, then it won't work. So there is authentication there as well. So the question is, can you get publicly available actions without being logged into Facebook, without using a Facebook access token? All of the actions are connected to Facebook users. So the actions are inherently connected to Facebook users, which means that they have privacy connected to them. So you won't be able to get just all of the information without asking for that first. There are endpoints that allow you to get your friends' data. So if we're building an app that wants to do some sort of social music sharing, then you can look and see what your friends are listening to, and you can get that as long as you have an access token for you. I think if you need to see the information that's been published from a specific app, you need to be able to get that from the app. So for example, when an action's getting published, we give back the app an action ID, and the app can choose to store that, and then they can categorize that themselves. So that action ID is not public, but the metadata that's attached to that could be used for like aggregating content across multiple users without access tokens. That's not something that the Graph API provides. Yeah, absolutely. So there's platform APIs for getting all the place information. You can attach that to actions, and you can attach that to objects. So actions can have metadata for the place, and that place can be a Facebook place ID. It can also have location information, which is just like coordinates. So it's the same with actions. So objects can exist in a certain place, but so can actions, right? So if you're listening to some music on the go, you can publish where you were when you listen to that music. You can attach that using the Facebook places. So that'll show up as part of the action, or it'll show up as the object. If it's part of the action, it'll also show up on your map in timeline. So it'll count as if it's a check-in. So for example, if I publish from, say I'm using some music recognition app on my phone, and I'm listening to a radio, or I'm in a shop and I recognize some song, that can publish to my timeline, and it'll also show up on my map, and it'll say that I recognize the song in this location. Any other questions? Does anybody want to meet Wolfie?
Basically, we had the social graph. The social graph is inside Facebook, facebook.com, but the open graph is outside facebook.com. But we had, before the first open graph, like we launched that like 2 years ago with the like button, or 3 years ago, I don't remember exactly. No, yeah, 3 years ago. And with the like button, we had the first version of the open graph to define your object. And the like button was where they were basically creating a page, an open graph page. And we enhanced that to create like any type of objects, because you can define whatever you want. So it's to define all the objects around your website, and after you can create the interaction, the social interaction with your user, and get this. Yeah, for the moment you have to do it manually. You need to replicate. Yeah, sorry. Export the data. I don't really understand what you mean. No, the first one. Like the action, you mean? All the action created? Yeah. Can you show the? Yeah. So you have the insights. So we're gonna give a certain number of insights, and you actually log most of it. You know, you log the actions, so you will have the data. After, you can do whatever you want with it, any amount of analysis. But with the insight, open graph, we're gonna give you some stats on. Yeah, of course. Yeah, we didn't pet enough pet. And we're gonna basically show you how we interact into Facebook. And for example, here is the number on the top, the number of actions published, the impressions that get on Facebook, and the referral traffic you get back on your site with those actions. And basically, you can as well plug onto the, if you have your own analysis, you can fetch the insights data, and after do the amount of analysis you want. And after, to replicate the actions, so the actions are per app ID, and you cannot automatically fetch the action types or object types and replicate them on your apps. It's actually not possible currently. So you have to do that manually. That was the second question, I guess. Yeah, to replicate the action, or to extend some of the actions. So you need to do your own app and create your own actions if you want to. But because they are namespaced, you cannot really have, enhanced, like create new action for an app that you don't own. To have a type of dog, for example? Yeah, you could add that into the properties. Yeah. Yeah. It could be a Labrador. And the Labrador could be actually it could be a composite object. Like Wolfie could be a Labrador. Two objects here. Yeah. Basically, we have three built-in actions. We call them built-in actions. They are listen, watch, and read, and they are restricted to music and newspaper and watch to video website, basically. And so those ones get a bit of different distribution. We have, the video dashboard, the news dashboard, and in your, I guess you all have seen in your ticker some, I don't know if you're gonna have some of them here. Okay, now there's no space for the ticker. And you're gonna have, some little icons on the ticker it's gonna say, watch. You can, just to see it's a video, it's just a little icons, but you get usually more distribution with that. And yeah, but you need to submit your actions, so we will review them, and they are built in, so they are defined by Facebook, but you can use them on your own, basically when you create your actions or your objects. Yeah, so you can set watch, and it's gonna be automatically the built-in actions. Not for the moment, but yeah, definitely we will consider that, but we need to analyze first the usage, and if there is like a lot of apps using the same action, like a lot of people who pet some pet, we will create pets, maybe. Yeah, but I cannot, like, for the moment, I cannot say like it's gonna be one, but definitely, yeah, if it's relevant, why not? Yeah. Yeah. Yeah, it's for that we have built-in actions, because we define the type of built-in actions, so our built-in object, and we know what they are. We don't really know what are the custom actions or objects, so it's a lot harder. But we can figure out a bit, but not as much as with a built-in action. Yeah, definitely. We give you distribution, qualified distribution, like connected user, because the friend's gonna see your actions, so the friend's gonna discover your app through those actions, and will give referral traffic to your website. So after on your website you can monetize, but you have known people, you know the user, and you can monetize as your mobile way to monetize, showing ads, or it depends what you do. But for example, it was very successful for our launch partners with Spotify, for example. Their user base, do you have the numbers? 4 times, yeah, they grow by 4x. Dailymotion, same stuff in France. Like we just give a lot of referral traffic.
So the pet use cases, I think the Tamagotchi is still making one of these years very successful, obviously. But Do you have any other interesting stories of how open graph specifically was used? So new types of objects that were created by one of your partners or the applications like that?
Yeah, like no, Pinterest quite exploded. Pinterest exploded with their pin, and yeah, so they had a lot of traffic, a lot of new users, and it's quite interesting the type of integration because it can be geolocated as well. So you can have maps. It can be very interesting, and they have as well. They have their mobile apps. So of course, think mobile first. And you can direct traffic to your mobile apps as well.
Foursquare did a great job as well. Yeah. So Foursquare started using Facebook Open Graph and Facebook map data. They're in the process of merging their own map data with the Facebook map data, so that it gets that map exposure that I was talking about earlier about the location-based actions. So they've done a really good job of that. So if you look at their Open Graph implementation, it's one of the stronger ones. Obviously, the social readers, the Guardian and the Washington Post. They've been big proponents of it, and we've learned a lot about the distribution model from that. So it wasn't like it was pre-existing objects, obviously articles or blog posts, and the objects or the actions, are quite obvious, like reading or agreeing with, disagreeing with. But it's been really interesting to see how the Guardian, especially, have integrated. Foodily, yeah. Yep. We are doing some ongoing research into that, about building toolkits for like real world presence. It's difficult at the minute because to interact with an app for the first time, we need to present a permissions dialog to users, which means that they have to be logged in on the device that they're interacting with. So that's a difficult thing, obviously, if you're building a kiosk or something for doing a physical check-in. You can't have somebody logged in on the device for a short term, pop open a dialog and then ask them to log in. It's not really possible. So there's a few things that we would need to do to improve that, but it is something we're researching.
With NFC will help a lot, because people already have the device to connect. The thing is with a kiosk, the problem is not you don't have just one user. It's not the property of one user. A phone is much different. So if you have a phone with NFC enabled, and you can have a discussion and a connection, so it's much better. But at the minute it's pretty restricted. But technology-wise.
So it's the same app. All the apps are namespaced. So when you're creating your app, you have to provide a namespace before you can even create any objects. So the namespaces are unique. So as soon as you fill in a namespace, it'll check whether it's valid. If the namespace is not valid, you'll have to add a new namespace before you can create any objects. So actions and objects will all be as part of that namespace, and the namespaces are enforced unique. I think we had a question over here somewhere.
Yeah, like the objects are public, but not the actions. The actions are not public. They are refined to a user. So you don't gonna show the actions. But if you want to, which use case will be for a private object?
You can't restrict that. So obviously all the objects have to be public URLs so that the Facebook linter can read the data about the object. You can do some privacy around that. So for example, as Alex says, you can restrict privacy to actions. You can move a lot of the data that's attached to those objects to the action itself. So while the object can have a lot of metadata, the action can as well. So for example, if it's something that you want to be private and you've got a photo attached to it, you can attach the photo to the action rather than the object. You could also build your app in such a way that the object only is only visible to people that are logged in and are allowed to see it. So that the privacy control can be set inside your app, and then you could just add like a publicly accessible URL for Facebook so that they can still lint or scrape the data for those objects. Yeah, we do. So in the app, okay, where are you heading to? Yeah. So inside the app, if you go to the object type, so once you've created a new object, we give you some basic code which shows you how to define the metadata for that object. So this is just some example like template metadata. All of the OG metadata is published as well in our documentation. So there's shared meta tags that are supposed to go on every object, and then there's custom ones that you add for the custom attributes that you're putting on there. So for example, if I go into pet, you can see that we've added some extra data called species. So that won't be there for all objects, but it'll be there for objects of type pet. Yeah, so you can see that species will be down here at the bottom. Scroll down. Oh, I must have not set it to be mandatory.
Our Debug tool, you can put any Open Graph Action ID or access token or URLs, and this is basically the linter. Is what's happening is our robot how he reads actually your objects, and here you can debug. So if you did some mistakes in your meta tags, we will show the errors. So here, yeah, I'm gonna stop here. And so here you have all the definitions. And actually, this when you do that, it pings it scrapes your URL and it creates the object. And you can as well, if you want, you can programmatically create objects we have a graph endpoint to do that. So they could be created before, or the first action will also create the object. Yeah. Your own access token? Yeah. Actually, we have as well test users if you want to do Selenium test as well, and you can also log in programmatically, and so you can run tests as well. There is a documentation on test users, and if you want to have your own test user, you can your own access token, you can just authenticate yourself. Yeah, this is for. So yeah, check the doc. Actually, this one is the new version for the authentication, and it's much better. The first one was a bit messy. Any other question? Do we still have time? No.
No more questions. I think we'll thank the lads for a very interesting presentation there on the Open Graph. We'll take a 5-minute break back at just after 8. So if you want to just get some stretch your legs or whatever, we'll be back in a few minutes. Fergal, do you want to get set up here?
All right, give a yell if you can't hear me at any stage or if the mic's dropping anything. Yeah, so I'm glad to see some people came back after the break. Hopefully I won't bore you. This is going to be kind of an unusual enough presentation. I'm going to present some sort of work I've been doing in my PhD, and also just kind of an introduction to social network analysis generally. It's going to be a lot of joint work here today from other people that I've worked with in the research group, some of whom are here today. So if you have questions afterwards, I can direct you to specialists in the area. So kind of the intro today. The agenda today, I have to give a brief introduction to social network analysis, sort of, well, what's this all about, where is this field coming from, before the sort of stuff I've done is going to make any sense. So I'm going to try and give that intro, and Sean's asked me to kind of talk a little bit about some of the tools and the technologies that we've used going about doing this sort of stuff. So it's a fairly developer audience here, so I'm going to try and do that. If there's not enough information about anything that anyone's curious about, feel free to interrupt me and say, hey, what's going on? Or you can ask questions at the end, whatever suits. So, yes, we're going to be talking a lot about networks today, graphs today. We just had a talk on the open graph, so I don't think I need to introduce an edge list and a graph representation. But, you know, graphs are networks, nodes and edges, simple graph theory stuff. So network analysis and social network analysis is actually something that sociologists have been doing for quite a while before the rise of massively networked data. And this is a really interesting picture. This is a picture from a sociologist called Moreno, where he has visualized little individual nodes there, little people as nodes, and the graphs, the sort of friendship connections are the edges between the people. And there's something really interesting about this picture, which is that the people he's divided up into clusters, into little subgroups, little sub-communities, and then kind of visualize the edges behind the communities. And that's from a piece of work called Who Shall Survive by this sociologist Moreno back in the 30s, so a long time before Facebook or graph APIs. And we've got an egocentric network there, sort of the view of the social world from an individual. It's been rendered by hand there back in the day, back in the 30s. So I guess modern social network analysis sort of traces its origins a good bit of the way back. Something that's very famous and sort of sets the scene for a lot of what people talk about is this idea of a small world problem. And this has been kicking around for a long time, but one of the famous pieces of early work on it is this piece of work by Milgram here in the 60s. There's something quite interesting here. So you're all familiar probably with this 6 degrees of separation, the idea that even a giant network like Facebook, that there's a relatively small number of individuals you have to pass through to get a path between one individual and any other individual. And this is a picture here from Milgram's paper that's sort of giving two conflicting intuitions about this. So one is that, you know, if each individual is connected to a fairly unique set of other individuals, and if there's no overlap between someone's social circle, the number of individuals that you can reach through a path of a certain length grows exponentially in the number of friends that each average individual has and the length of that path. So, you know, that's one view of the world, that of course it's possible to get across the entire world in 6 degrees of separation, because, you know, if the first person has 10 friends, and with one hop out from that, everyone is 100 friends you can reach. Another hop out, there's 1,000 friends you can reach, so it's growing exponentially. But then the conflicting possibility would be that social networks are extremely highly clustered like this, whereas, you know, when you have one individual and you add another individual, so you got C there, and you add, I don't know, maybe this friend of theirs N to your model of the network, that really you don't actually add many more friends at all to your network, because of this clustering, you don't get to reach many people at all. So there's sort of a tension there between the two different views of the world that Milgram's talking about when he's trying to discuss this whole 6 degrees of separation problem, the small world problem. Another piece of famous research that sort of, again, early sociological research that sort of sets the stage for how the problems we try and think about now is this piece of work by Granovetter on the strength of weak ties. I don't know if anyone's read The Tipping Point by Malcolm Gladwell. It's sort of quite a famous, popular book about product adoption that sort of really popularized some of these ideas recently. So what's Granovetter saying here? Well, he's saying a lot of different things in this paper, and it's sort of a lot of complex ideas in this paper, but he's really talking about, one thing he's talking about is is ties that are weak. So people that are sort of your acquaintances or that you're less close friends with, that they're more likely to be ties that are also structurally weak. That sort of, they're not in triangles, they span the gulf between different community structure. So Granovetter really talks about this. And he kind of, in his paper, has this sort of surprising idea that he interviews a whole lot of people, and he finds that the people they get job offers from, that they kind of that help them find employment, are actually their weaker ties. They're not the people that they're really close friends with, because those really close friends are within communities. The people that really bring new information to you are the people that you're sort of more weakly linked with. So that's the sort of the strength of weak ties thing about the idea. Now, there's a lot of different meanings when people say weak ties, and it's kind of complicated thing to sort out exactly what's going on when someone starts talking about the strength of weak ties. But those are some diagrams from Granovetter kind of setting that scene. So I'm going to skip forward a bit now to the 70s to another piece of research that's highly influential on some of the stuff I'm going to talk about recently. And this is a piece of research by this sociologist or anthropologist, Journal of Anthropological Research, Zachary. And what's going on here is that you're seeing sort of starting to become a sophisticated network visualization here of people that were in a karate club together. And actually, each node, each one of these 34 nodes is someone in the karate club. And there's a link between two people that socialized with each other or sort of had some sort of a social contact with each other outside doing karate training. And it's quite an interesting graph because this club, there's sort of an internal political power struggle or something like that in the club that caused the club to fission. It caused it to divide into two separate clubs. And the line at which people fissioned, the line at which it divided, was sort of predictable from the edge clustering of who used to socialize with each other, and actually algorithmically predictable. So this has become quite an important piece of work that motivates or is used as motivation for community finding algorithms, which we're going to talk about in a minute. It's kind of harder to see in that last visualization, but we now have sort of modern force-directed layouts cheaply available on any computer, and we can do this sort of spring-weighted force-directed layout here. It's the same social network you've just seen, and you can sort of see that this guy was the leader of one half of the fission, and one of these two, I forget which, was the leader of the other half of the fission. And you can sort of see when you use this force-directed layout that, yeah, the karate club socially is sort of polarized there. It's sort of there is sort of a fission line you can sort of see. So, okay, that's kind of a lot of stuff that's been done in sociology in the past, and there's sort of more recently, there has been sociology done all the way through, but more recently there's a lot more people interested in this, maybe physicists and computer scientists, and maybe that's even annoying to some of the sociologists, but they're sort of interested in this and studying large data. Those are some pieces of work that's very interesting in sociology that I personally feel kind of underpin what's going on now. So sociologists did some really amazing things considering the constraints of data and equipment they had at the time. But nowadays, right, we've got hundreds of millions of people on social networks. There's massive online communities. The sort of the Web 2.0 movement has resulted in a lot of user-created content and user-created data that's out there to mine and analyze. We have more memory and more compute to investigate these things than we ever have before. And this has sort of led to a recent massive development in interest in social network analysis from a kind of a hard quantitative point of view. So here's some papers that are pretty important in that. One paper is this Duncan Watts and Steve Strogatz talking about these kind of short path lengths that we talked about before, that, like, you know, how there's a short path through the entire social world, your 6 degrees of separation idea. These guys are sort of doing something interesting here. They're showing that if you have an extremely clustered network, so that basically you have a completely regular lattice-like network there on the left, or if you, there's quite a high path length in this network. There's a lot of hops to get from anyone to anyone else. Whereas if on the right there, you have a completely random network where everyone is just connected randomly to everybody else, there's quite a low path length because of the randomness of the network. And that's sort of a well-understood thing from graph theory for a long time. But what Watson Strogatz showed that's really interesting is that if you have an almost clustered network with only a small percentage of random paths, as you increase that percentage of random connections, random social connections, random paths, as you increase that percentage, the average shortest path length in that graph really plummets very fast. So basically, you can have a highly structured, highly clustered social network with only a certain amount of randomness, and you end up with a very small shortest path length. And what was very interesting about this is they're starting to look now at these large empirical data sets. So film actors of, pretty sure that's the IMDb data set. It's so popular. A power grid data set and sort of a small worm, basically, C. elegans, which is well studied, its neural network. And they're kind of showing that in all these things, you have kind of a low average shortest path length and quite a lot more clustering than you'd expect in random networks. So this is sort of interesting. They're sort of saying, okay, we're starting to study networks. There's a lot of these networks from different sources that seem to have something in common with each other that we don't see in random models of networks that similarly. There's another famous paper here, Barbassi and Albert. And what these guys are basically showing is that the degree distribution, so that sort of the number of people with a certain number of friends, you can think of it as, seems to follow some sort of irregularity that we wouldn't expect. And these guys have actually said it's sort of a power law degree distribution. Some people have come along recently and said, well, a lot of things look like a power law if you just look at them on a graph, and it's sort of hard to really tell whether something's a power law or not. You need to do some good stats in that. But basically, the interesting thing is there does seem to be some sort of irregularity. It's not the case that in each of these networks that you're looking at there, that the average number of friends someone has is normally distributed with a really low variance. You're definitely seeing heavy tail distributions. So there's a few people that have an awful lot of friends is the basic thing. If you look at actors, the one on the left there is actors. There's a few people that have been in an awful lot of movies. The World Wide Web there in the middle, there's a few web pages that have an awful lot of incoming links. It's not like normally distributed. It's not the case that they all have roughly the same number of links or connections. So, yeah, okay, so next thing here is, we're really jumping around here trying to set the scene. Next thing here is a paper on K-clique percolation. So this is kind of saying, okay, you have all these networks. These networks seem to have something in common with each other. Let's say you want to find structure in these networks. How do you go about doing that? Because there seems to be some intuition that, there's something similar about these networks, and that maybe you can develop algorithms that will find structure, find community structure. So basically we'll take individual nodes and edges and we'll pull out the higher level structure from those that'll sort of work across a wide range of networks. And this algorithm, this CFinder algorithm, which is an implementation of K-clique percolation by Pala et al. It's one of the first really big papers published in Nature, and that's kind of trying to develop an algorithm to pull out this structure. And I won't go into the exact specifics of what it does, but it basically gets sort of dense groups, gets fully connected subgraphs that overlap each other a lot, and looks at a set of fully connected subgraphs that overlap each other a lot and says, oh yeah, this is a community. And you can sort of see a visualization there of the overlapping communities it gets. Another famous community finding algorithm here is by this guy Newman. And again, communities are these kind of sets of structure in a network. And this is the Karate Club here again, a different visualization of the Karate Club. And this is an example of I think that's the split that actually happened there is a dashed line. And then the whether a node is a square or a circle tells you what a community finding algorithm, so basically the community finding algorithm has found two different communities there. One community membership is denoted by circle and one by square, and basically that corresponds exactly to the actual split that did happen in that Karate Club. I might have it the other way around, but the point is the two are completely predictive of each other. At a personal level, this is my Facebook network of about I don't know, a year ago or 6 months ago or something like that. And what's interesting about this is the egocentric network that I'm in, so it's the people around me and that we're friends with each other. And a community finding algorithm. So force-directed layout has laid out the positions, but a community finding algorithm, modularity-based community finding algorithm, has actually assigned the social groups. And these are social groups that make a lot of semantic sense to me. I did computer science in college. These all happen to be computer scientists. Some of them might be in the room, I'm not sure. People I did sort of sport orienteering with, a different sport I'm in. And you can sort of see overlap between the different communities. But sort of the key point here is that you can have an algorithm that does a pretty good job at figuring out this social structure based on edges and nodes. So the one thing we've been looking at a bit, starting to talk about research I've been doing with other people, one thing we've been looking at a bit is networks sort of look different at scale. Everything we've seen so far has been relatively small scale networks. Modern online social networks such as Facebook and so on, we get some data from that, show us that social networks big online social networks have a very overlapping community structure. And so one piece of work that we've been doing is kind of examining this idea. You saw it a little bit there at the cake-leak percolation, but again, a lot of people then started partitioning up networks, finding communities by breaking networks up. We've kind of been looking at this idea that it doesn't really make sense in a lot of social contexts to break communities up like that. So one of the first research questions I guess I looked at is, what's the sort of structure of the overlapping network look like? So we've talked a lot about network graphs. If instead you say that each community, each group, each social grouping of individuals is an individual node on the graph, and the overlap between social groups are edges in the graph, could the community overlap graph look like? Well, if there was no overlapping communities at all on the network, if it made sense to completely partition a network, it could look like that, right? No overlap, nothing really going on there. You could also have it so that communities in a network sort of are heavily clustered and do overlap with each other. So it's not the case that I'm only in a community of computer scientists or only in a community of orienteers or whatever it is. But in fact, each individual could be in a couple of different communities, but maybe those communities are still partitionable from each other. It's also possible that community overlap structure, everything overlaps and there's no partitions you can make in the network, but there's it isn't sort of densely, tightly overlapping. And then the final thing is that, there's short paths through community overlapping structure. We did some work on trying to quantify which it is. And it's kind of it's a subtle area. I'm not going to go into it in huge detail, but I will show. This is an algorithm called MOSES, which is a model-based kind of statistical overlapping community finding algorithm by McDade, who's in the room here actually. And what this algorithm does here is it assigns individuals into communities. And what we've done here is we've visualized the overlap between communities. This is Facebook network from a set of Facebook data that's available, and it's the Facebook network of the Princeton University. And what we've basically done here is each node there is a community, and there's an edge between communities and the overlap. So we get this really complex, really overlapping social structure when we apply algorithms like this to real graphs. And that's it. It's very hard to separate out structure visually in a large network. Things really do overlap each other very much so. So, so this sort of affects, I'm going to skip through this kind of fast. This sort of affects how we think about this sort of role of weak ties. One thing I looked at here is the importance of structurally weak ties. So social ties that aren't in triangles, and looks at the importance of them on the average shortest path length in a network. I'm going to gloss over this a little bit, but you basically have a visualization of a network here where the weak ties, the ties that are not in social triangles, are in dashed lines. And one thing you can do that's interesting is you can calculate the average shortest path length of a network. If it didn't have those ties, then you can calculate the average shortest path length in that network if you put those ties back in, and you can look at the difference between the two ties. And on a lot of networks, these sort of weak ties are really important for making the network short. But we find on modern online social networks like Facebook, you don't really need those sort of structurally weak ties to make the network short. And this affects how fast behaviors in social groups, kind of high-risk behaviors in social groups, where you require more than one other friend to adopt that behavior before you can adopt it. It affects how fast behaviors like that could potentially flow. It affects how much the network structure limits them. So this is a simulation I've done. There's a graph of Twitter with 27 million nodes in it and 1.5 billion edges. And you can do simulation on this graph of contagion processes, and you can sort of empirically investigate how much the network structure limits that. That's sort of a diffusion process. Simple simulation code there in Python and so on. Okay, so I want to talk a little bit very briefly about the tools we use to investigate questions like this. And this is probably going to be, unless there's a lot of sociologists in the room, this is probably going to be the most controversial slide here. So we could use Hadoop and big data tools to attack this stuff, but we don't really tend to do that. And it'd be interesting to get some feedback on people. It's kind of complicated why we don't tend to do it. But we find that typically, like a large single memory architecture machine and flat files, surprisingly effective in terms of our programmer time and cost effective in terms of hardware acquisition. We get a lot of mileage if we want to analyze a big network like a Twitter network by writing sort of efficient C++, right? And by keeping our data in flat files and no SQL, no SQL, just flat files for everything. Because we find that if we have something like a network like the Twitter data, because it's so unpartitionable in the way we've discussed, and if we want to do something like a contagion simulation across that, that network data is very large. Even to store that network fully in memory on one machine takes something like 60 or 70 gigabytes of RAM like that. So we find that no one really seems to know yet what the right way to try and take that graph and cut it up and partition it and put it across a large array of different machines to efficiently do fairly random access, fairly low coherent computational tasks is yet. So we tend to work a lot without using the modern big data tools. And I'd be very interested to get feedback from anyone else that's tried to do stuff like this. Not sort of CRUD stuff, create, read, update, delete stuff, not that sort of stuff, but sort of fast algorithms that need to have very random access to the network. Very interested to talk to anyone that's had good experience with massively parallel tools and that. And again, there's the other thing, which is that as research students, we tend to just need to test one hypothesis. We need to write the code once, ugly, horrible code, throw it away and move on. You know, it needs to work, it needs to be correct, but it doesn't need to be production capable. So I'm curious to see what people's feedback on that is. Another tool we use a lot is for small-scale network analysis. It's this NetworkX library that's in Python. If anyone wants to play with this sort of stuff, if you want to analyze your Facebook network or anything like that, NetworkX is really great. It's an open-source library. It's out there on the web. And it's got a very nice, very Pythonic interface with which to load up complex networks, to work with them, do connected components analysis, more complex things like page rank, calculate the min cut. There's even some community finding algorithms in there. So, if you wanted to visualize programmatically your Facebook graph, or if you wanted to build an app to do that, NetworkX is probably an interesting place to look at. How are we doing for time, Sean? Okay, right, cool. I won't go through all the rest of the stuff. Okay, I'll just mention briefly that I talked a little bit before about community finding algorithms. This is a Facebook network, an egocentric network of one individual, and you can really see on this network that this individual is in several different communities. So myself and a few people in the research group, including Conrad Lee, who's here, is one of the main authors on this, kind of came up with this community finding algorithm called GCE, which basically starts off taking these dense subgroups and kind of trying to add more nodes to a dense subgroup to try and find communities that way. And it does reasonably well at the task of predicting. So these are college Facebook networks, and the students have a dorm in a Facebook network, because we actually get information which students shared the same dorm. And you can sort of make a stab at predicting which students were in the same dorms, where the dormitory sharing groups of students were, just by looking at the groups of friends on Facebook, which is kind of interesting. You can really find communities that have some sort of a real semantic meaning just from looking at Facebook data. That's something people maybe need to think about a little bit. There's a lot of information in Facebook data that maybe people don't realize is there. I'll skip this research to try and make faster click percolation. I'll mention briefly last couple of slides here, some work myself and another researcher, Martin Harrigan, did on Bitcoin, this is basically an interesting application of network analysis, which that, sometimes if you can treat something as a network and apply these sort of network analysis tools to it, again, you can sort of see structure that that's maybe not obvious to see otherwise. So we use some, again, Python tools, NetworkX, which I talked about before, Bitcoin tools, and Graphics to do some visualizations of the Bitcoin network. We discovered something interesting about the Bitcoin network, which wasn't totally unknown, of course, but maybe people didn't realize how widespread this issue was, which I won't go into the details, but Bitcoin sometimes allows you to link up Bitcoin addresses that are quite different and sort of resolve them as both being from the same user, same wallet. So this enabled us to kind of, this coupled with some visualization techniques we had, enabled us to sort of start making some sense of bits of the Bitcoin network and treating it again as a network with lots of kind of clustering, and which we didn't expect to see in it. These sort of visualizations here, the color of a node and the width of a node corresponds to the amount of money, the amount of Bitcoins, which have an exchange rate, which are in that sort of node at any one time. this is kind of interesting because we could resolve the identities of some individuals that have been, say, donating to WikiLeaks or donating to other organizations on Bitcoin and stuff. And that maybe that surprised some of the users in Bitcoin, and that it wasn't maybe as anonymous as some people. Not definitely some people knew about this, but some people built it as. And then we did a piece of work as well. Diary's not coming out so well. We did a piece of work looking at a theft in Bitcoin of what on the day had a very large US dollar value. And again, this sort of surprised us that here's this big currency system that we could treat as a network with a very kind of interesting network representation of it. Apply visualization tools. This is done with Python and GraphViz, and actually really see some sort of interesting structure coming out of this theft. So like we can sort of see, this is the guy that reported the alleged theft, and this is the address, the Bitcoin address that corresponds to the alleged thief. You can really see that very shortly after the theft happened, you can see the money being moved around between many newly created Bitcoin accounts and probably being attempted to launder it. And you can see it's just interesting to see how it moved across the network quite quickly, and there's a real story behind this picture. And it's been kind of filtered out and been sent to a big account service there, My Bitcoin, which is that big red, huge dollar value node there, which acts as an exchange to US dollars. So we're kind of surprised at how much structure we managed to unravel from this. One thing that we thought was interesting is by this node C there is a whole load of different accounts that we sort of resolved to be the same account. And it was interesting to see, we saw these separate flows of money that disappeared for several days and then all transferred into node C in the one transaction at the one time later on. So, maybe this stuff wasn't majorly surprising to some people, but it's quite surprising to us that we were able to really take this kind of complicated transaction system and apply network analysis to pull structure out of it and start to pull meaning out of this system. So that's it. That's some of the sort of stuff we do in network analysis. It's a bit of a whistle-stop tour there, trying to what the hell is a network, or what do we mean when we talk about network analysis or structure in networks. But hopefully that made some sense to some people. If any questions, if we've time for questions, I'm happy to take any questions. So, questions?
Where do you get all the data for Bitcoin stuff? Like, you have to have Bitcoin. Like, is there some sort of trail on it? But how do you get all that?
It's a good question, and it's kind of complicated. But Bitcoin's a really interesting system. It's designed to allow a currency system where you can trust that when I sent you money, that you definitely got the money, that you can trust that, but that there's no central authority. You don't have to go to a central authority and say, hey, did Fergal send me this money? But instead there's sort of this peer-to-peer network that establishes a consensus about where the money is. And in order for that to work, as they've implemented it in Bitcoin, one of the conditions of the network is that there has to be a ledger of all the accounts that's kept and that's distributed throughout the network, that everyone has to know the ledger of all the accounts. So where the anonymity or the security of identity, such as it is in Bitcoin, comes from, is because we don't necessarily know who owns each specific account. So it's sort of pseudo-anonymous like that. We don't know who owns each account. And a lot of people, not everybody, but a lot of people thought that pseudo-anonymity granted them real anonymity. But actually it turned out that it was easier than a lot of people thought to link different accounts together and to sort of say, oh, well, I know that that's Johnny over there, and I know that that account is the same as this account, and this account's the same as that account, therefore I know that that's Johnny over there, and so on. So, yeah, it's a bit involved, but answers your question. Other questions? Commercial application of research. What the hell? So first off, research doesn't necessarily need to have a commercial application, which I believe a lot. But unfortunately, this research actually has a lot of commercial application. in that, like, so like, where to start? I mean, so So I'd start talking about there's industry partners in the research cluster, right? One of the industry partners is a company in Dublin called Storyful, and they're really interested in finding out kind of breaking stories that happen on Twitter, right? So basically, there's a lot of information that news stories that breaks first on Twitter, but there's a real problem of finding out, is this person a troll, or are they authentic, or is this a real story? And, you can sort of try and figure out, based on the structure around them, or based on how something moves around the thing, or based on reputation, whether something's legit or not, or whether something is exaggerating or is breaking off. So that's one potential commercial application. I mean, so we're in Google's headquarters, right? We've got to mention PageRank or whatever. PageRank is a structural network measure that has a commercial application. So there's no reason why other ones mightn't have commercial applications in future to solve similar problems. I talk a lot about that, but I'm not sure that research necessarily needs to have a commercial application, but yeah, it'll come in future. Yeah, I mean, right, this is full of stuff. The commercial application of Bitcoin stuff, I'm not sure. I think it's pretty interesting to know that if you have a big complex system like this, that you can get more structure from it than you think you could. Maybe something this could be applied to looking at financial transactions or something. I know there's other people in networks that have applied network analysis to try and look at financial transactions and patterns, so I don't know. Big question. Other questions?
Well, possibly related to the previous question. The reason I came here today is because one of my clients are trying to do this open draft book. It's 19. They want if their people use the interest story that kind of practice the outside for 19. And I'm assuming that that's what their aim is then, for you to see their friends using 19 and trying to do the same parts of the same thing that they'll spread that way to 20. And that's obviously the first application.
So I guess one thing I've been interested in a lot is diffusion processes in networks, and diffusion of information or influence in networks. There's a lot of information out there on that. There's a lot of research on that topic. Yeah. How commercially available that research, or I'm not going to say it's early stages. People have developed stuff like that and deployed it, but I still think it's a very hard thing to study how much someone influences their friends. Like, we've some famous studies like your friends are making your fat sort of interpretations of the Christakis and Fowler study, and organizations in Ireland have put ads on TV or on YouTube or whatever about that sort of thing, and it's very difficult to really pin down how much people are influencing other people. It's a big debate. So, but definitely, I think there's interesting things to be learned from reading that research if you're in that domain. Definitely, yeah.
So thanks very much, Fergal, for giving us. I think it was very complimentary to the stuff that the guys on Facebook talked about earlier. I have a couple of short notices. We're just before we go. Okay, so just a couple of things. I always mentioned Google I/O. That's on June 27th, 29th. We're having an I/O extended event. Almost certainly, probably be here. We have to sort out the details. Last year we did nothing except streaming I/O content. That didn't work terribly well, so there has to be an extra hook or incentive for people to come down. So we're trying to do that. Google themselves are trying to make it, let's say, an event where people at the I/O Extendeds can actually talk to the Moscone Center in San Francisco when it's on. I don't know really how well that's going to work, but that's kind of what they're trying to do. For anybody who's interested, Startup Weekend Belfast is on May the 18th. Dublin Beta is on, I think, next week, April 30th. UL, the iPhone OS X development conference is on. I think it's sold out. Looks like a really good lineup. Open Geodata Hackathon, Hack the City. The NDRC asked me, it's right down at the bottom there, so the one thing that I was asked to kind of notify people about is they have this program called Swequity. Swequity, I have a few flyers for it if anybody is interested. They're trying to bring together guys who've got some ideas with techies, and I won't say exploit the techies, but let's say leverage their skills. So I'm a bit, I don't know how that's actually going to work. But it's a program. They want to get people to kind of meet up and talk to each other. So maybe something useful will come out of it. It's happening around the June timeframe, I think. Next one, we haven't got a topic really for the next one. I was trying to do a shout out to students to see if they'd be interested in presenting their work. We got one undergrad student who came back to us and 2 high school students who came back to us. So that I think said a lot to me. We're still looking at organising a cloud focus event, and after the security stuff from last month, the OWASP guys are interested in doing like a capture the flag thing with us, so we haven't really got the details not sorted out yet. Please return your badges, so the guys in Google want to hold on to the badges. Also, if you've brought anything into the room, like cans of Coke or whatever, maybe you could just bring them out of the room with you to make sure the room is left in a reasonable state after we leave. That's all. So we're going to go down to the schoolhouse for a drink as usual. I think there's been an issue that some people might have gone for a drink, but we were left here tied in the room. So I think I'm going to just say to Brian, do you want to put your hand up there, Brian? Brian is going to lead the charge, I think, down to the pub, and then we'll be down in a few minutes after that. So the next session, actually I didn't put the date of the next session, May 29th, I'm not 100% sure, it's May 29th, it's last Tuesday in May. So hopefully I'll see some of you guys then. That's all for folks.